Okay, cool. So this is, um, oops, I copied it in the wrong place. 1 second. Yeah, this is yesterday's or day before yesterday's. This is today's. All right, cool. So let's get started. So today we'll be covering the remaining pieces of object-oriented programming. Yesterday we mainly covered inheritance as a key element, and then we looked at uh, how we can control access using access modifiers, right? Public, protected, and private members, and how we can restrict who controls access to what. So this is, we're just continuing it. The implementation that you see here is exactly what we finished implementing um yesterday. Sorry, day before yesterday. So today we'll be mainly looking at uh, two sort of remaining key concepts. So the first one that we'll be talking about is abstraction, and then the second one will be polymorphism. So if you've studied object-oriented programming in your curriculum, you might already be familiar with both of these, at least in theoretical sense. Today we'll be looking at, from a very practical purpose as well, how we use these and what this really means when it comes to coding. I just recalled that the other day we didn't talk about this. We posted this question as to why does the main function in our C++ programs, why does the main function has an integer as its return type, but even though we're not really returning anything, it still works, right? Like I can still do return 0, and that also works. Even if I comment out this code, that also works, right? So why specifically int? Does anyone have a clue about why? No. Okay, so if we remember, we can create both types of functions, right? Like we can create functions with no return value. In that case, we use the term void, and otherwise we can also specify something with a return and a specific type, like an integer or a character or something, right? And in that case, it will be uh, returning that specific type of data, right? But here, if I put void main, then it says main must return int, right? So the reason for that is that when we run the program, so right now we are using repel, but later on when we try to run it directly from command line, if you have like a local compiler installed, like Turbo C++ or something, or GCC, um, in that case, while running from the command line, whenever there is a return 0 at the end, because we are calling the function from command line, because we're calling the code our .cpp. First, we'll compile the .cpp code into a.out file. You would have seen like a binary kind of a file, and then we'll cover the exact details of how this happens once we are further into the program. So if you're not familiar with it, don't worry about it. But one of the key things to understand is that in Linux, kind of operating system, um, whenever you run a code or whenever you run a program, if it returns a 0 output, the operating system thinks that everything went fine and the program ran successfully. There were no errors. Anything apart from a 0 return value indicates an error kind of a scenario. So that is why if the program has run successfully and finished and reached this stage and it says return 0, it indicates to the caller, whoever called this program or whoever started this program. Most cases we are starting it from like command line or something like that. That indicates that this program ran successfully. And that is why main function always has an integer return type, and you'll see like a lot of programs, um, right, like return 0 at the end, right? In case some of the things causes an error, anyways, your program will stop before. It won't reach this return statement, right? If this line has an error, then it will just stop there, right? So this will never get executed, and because of that, your integer value 0 won't be returned. So the operating system would know that the error has occurred. So when you return 0, the operating system thinks that okay, everything is good, the entire program ran successfully, all is great. So that is why main returns main has an integer return value or an integer return type. All right, cool. So now let's continue on to, oh, by the way, hopefully everybody got that, understood the reason behind it. You can Google for it. It's a pretty straightforward thing, but it's a very kind of a specific behavior um, that, is kind of like a special thing here. But normally, uh, uh, like most of the time when you build something, application or something, web application or an Android application or even a game or something, right? Like they don't need this kind of thing because main is usually like hidden away. Somebody else takes care of calling the main part and you just build your own application. So most of the time you don't need to have like a main function. All right, cool. So let's move on to our first core concept called abstraction. Um, Not the first, but actually the third concept. So day before yesterday, we covered the other two, and the third one is called abstraction. So what do we really mean by abstraction? Does anyone know? Be it in the context of object-oriented programming, or be it just in like uh, abstraction as in like an English word itself, right? Like what does that really mean? So can anybody explain? Anyone? Yeah, okay. So hiding the functionality of the program. Okay, that's good. Anyone else? Would anyone else like to add to that? Right. So as I mentioned in chat, yes, when we say abstraction, first let's understand the English meaning of the word abstraction, right? Abstracting away means just hiding away a lot of the complexities, things that are not needed, right? Things that are not required in the current context. Okay. So a good example of that is when you talk about any sort of a complex, say, like an appliance or something, right? Like again, taking the example of a phone, um, in order to buy and use a phone and make a phone call, do you need to know how the internal circuitry is, how the RAM is attached to the motherboard, what kind of a chip is needed, how it is, functioning, if it breaks down, to fix it? No, right? Like in order to use this device, right, I don't need to understand the inner workings of it, right? And when I say that, it's basically specific to a context, right? But the factory that makes this device, for them, it's important to understand the inner workings, right? But from an end user perspective, it's not important, right? And that goes with same with like any complex object that you see around yourself, right? Like you have a Wi-Fi router, you have a car or a bike or whatever, right? Like you do not need to understand the inner workings of the system in order to use the system, right? So from your context, those complexities needs to be abstracted away. Yes, you need to know how to use it, right? You need to know how to operate a touch screen. You need to know how to unlock a device, right? You need to know how to turn the ignition of a car on in order to drive a car, right? You need to only know how to operate it via the right system, right? But you don't need to know how to build it, right? How to make it yourself, or if it breaks, how to fix it, right? So that is what abstraction is. Now, when we put it in the context of programming, um, Now, can you think of relevant examples? So actually, we covered abstraction in pretty much every class. In the last two classes, we covered abstraction. I just didn't tell you that this is abstraction, right? But if you look at the program right now on the screen, just this player class, right? Can you give me an example of where have you used abstraction now that you know what the meaning of abstraction is? We've already used it in the last two classes every time we have written any piece of code, right? So can you tell me where have we added abstraction, or how do you think within this player class, we've used somewhere abstraction, a key concept of abstraction? Anyone? You can use the mic as well if you think you have some ideas around it. Okay, so let me explain. Um, what were we trying to do when we were implementing this take damage function, right? Anytime somebody uh, attacks my player, right? All they care about is that my player should take damage by that X value, right? Whatever is that X value, 50, 100, 1000, could be anything, right? That enemy doesn't care how my player health is implemented internally, how my what is my current health value, whether it's 1000, whether it's 1 crore, whether it's 10. That enemy doesn't care. All that enemy does is cares about is that I hit this player and this player should take damage, right? So because we created the health as a private thing and then implemented this take damage functionality on top, what we did was we abstracted away all the complexity in the system, right? Now the enemy doesn't need to worry about, hey, did my player's health go down to zero? Is the player dead? Is the player still alive? Can the player take damage? All those details to that enemy are irrelevant, right? What my enemy is concerned about is that if I am an enemy and you are a player and I'm hitting you with my sword and my sword does 100 points of damage, then the moment I hit you, then you should take damage of 100, right? So as an enemy, I should be able to call a function on the player and say, player, take damage, value 100. Rest is your inner thing. If you have a shield, you might reduce that 100 damage to 50 and then take 50 damage. If you don't have a shield, then you take 400 damage, right? And then whether you die after taking that 100 damage, whether you live, whatever happens is all internal complexity. Okay, so every time we created a private member that is local to the context of my player or whatever class we are talking about, and then we expose certain public things on top in order to access it, modify it, like tweak it, adjust it, whatever you want to call it. Um, all those things are essentially examples of abstraction. Okay, so similarly, like if you think like we were implementing a refrigerator class, right? A refrigerator class would have like a temperature as the private attribute, right? And then you would have increased temperature and put in the value of int, you know, increase value. And so you will have a function called increase temperature. Internally, it will check what is the maximum temperature that the refrigerator can be operated on. Can you increase by the amount that somebody is requesting you to increase it to, right? All those details are inside this increase temperature function, right? The caller just says, hey, increase your temperature by 5 degrees, right? I don't care. As a caller, I don't care how you increase it. I just said that I want to increase it. I'm operating you, right? So as an operator of the system, I don't care about the internal details. So that's another example of abstraction. So we've been using these kind of things, get health, right, which is a public thing which lets you return this outside in case somebody needs it, right? But imagine there was another, intern, there was a shield as well that the player has, right? And the shield starts at 50 points, right? Now your health at any point, your total health at any point would be your health plus your shield, right? So first your will modify the take damage function so that first shield loses point. When shield goes down to 0, then health loses points, and when both go down to 0, then you die, right? But then outside my player, the enemy doesn't care whether your shield absorbed that damage or whether your health absorbed it, right? It just cares that, hey, has your health reduced by that amount, right? So this is how, when we talk about abstracting away the complexity of the system, this is exactly what we mean. Okay, cool. So I don't think we need to implement something separate for this, because uh, practically we've been implementing this pretty much from the last two classes already. So hopefully this is clear. Anybody not clear on what abstraction is so far? Everybody good? Yes, no? If yes, then we can move on to the next system. Otherwise, if there is any specific doubt, I can take the time now to explain it again. Okay. All right, cool. So I'm gonna take it that everybody has understood. All right, cool. So polymorphism. Right? Anyone what polymorphism is? Has anyone studied it, heard the word, know about what exactly it is?
Ability to have more
Ability
than one
to,
form.
yeah, okay, carry on.
Okay. Yeah, that seems a very a textbook kind of an answer, right? Like ability to have um, multiple forms, more than one forms, kind of thing. So yeah, but you guys are correct. So um, generally, when we say polymorphism, uh, the literal sense of it is basically that based on my caller's sort of requirement, internally I'm going to call a different thing, right? So Sai mentioned, right, having multiple forms like overloading and overriding. So generally speaking, um, what that usually translate into, without going first into overloading and overriding, um, generally it means that based on the current context, some other code might get called, right? So uh, you might have uh, take damage as one function, but internally there might be two versions of take damage, right? So it might have one that takes a damage as a fixed amount and the other that takes damage over time, right? So if you had another take damage function which takes int damage but also takes int seconds. So this indicates that the player takes damage over seconds. So this damage, it does not inflict immediately, right? It so if your damage value is 100 and seconds is 10, that means the player is taking 10 damage per second for the next 10 seconds, right? Whereas this damage function would be something like, hey, take this damage now, right? 100 damage means 100 health reduced immediately, right? So the implementation of this versus this will be very different, and depending on the context of the caller, whether this will be called or whether this will be called will be decided. So if I have so we implemented this in the player class, right? So in this case we might call 60 comma 10, right? Now even this is a valid function, and in this case it will call the second one and it will do 6 damage per second, right? Whereas this will do 60 damage immediately, right? So it's as good as saying 6 and 1, right? Now these two are exactly the same, right? Because internally we are saying that this does X amount of damage over this number of seconds. So this will do 60 damage over 1 second, and this is exactly the same as 60 damage right now, right? So now this will get called to the original implementation that we had for take damage, this one, and then the second one will get mapped to this one. But so this is typically what we call as method overloading. So generally, are you guys familiar with whether it's compile time or runtime? So when does this decision get made? Is it at compile time or is it at runtime? Anyone? Okay, guessing you guys aren't familiar with that concept. So let's dig a little deeper into it. So typically we know that C++ is a compiled language, right? So we first compile our entire code that compiles into an intermediate language, and then that language gets run at runtime, right? Uh, so what does that actually mean? So when I say whether this happens at compile time or at runtime, now when the compiler is compiling this code and checking for errors, right? When it encounters this line, right, it knows exactly that you're trying to pass in only one function argument. Okay, and then it tries to find which take damage methods implementation takes in one argument, whether it's this one or whether it's this one, right? If it says, oh, I found this one and this is the correct one, integer is the type and there is only one argument, then this first implementation or the first function call will get mapped to this, right? In that case, the compiler at compilation time itself is able to make that decision because there is no ambiguity in the system. There is no uncertainty. It's exactly the player class. It's an object of the player class. It's calling the take damage function and it's passing exactly one argument of the type int. So everything is known in this case. Okay. So this is basically compile time. Same in this case also, right? It knows that it is exactly an object of the player class. It knows exactly the function that it's calling, and it knows exact number of arguments and the type of these arguments when it is compiling the code itself, right? Because of that, this is called compile time. So method overloading is compile time. Okay. So that's what it means by compile time. Anyone knows what method overriding is? Anyone? Okay. So method overriding is the second type of polymorphism. Same method in different classes. Okay. Yeah. So as I mentioned, essentially it's saying that we have the same method but in different classes. So what does that mean? So when we are looking at these two take damage functions but with different number of arguments, right? If I try to implement another take damage that takes an integer, again something like this will give me an error. I cannot implement this because the compiler says that, hey, this is already a function that has the same name and the argument list is also the same. The name here doesn't matter. I could call it DMG and there still be an error because it's not checking for this variable name. It's checking for the type. So int matches int, take damage matches take damage. So when somebody calls this take damage function, it's not able to identify which one of these two should be called. Because of that, it results into this error. So you see the error says it's redeclared. It's been declared again, right? So for that to happen, we either need to change the name of the function, or we need to change the types of argument. Okay, so imagine here I say that this is not an integer, but instead it takes double as the damage value. Now it can identify based on the argument what I'm passing, that whether I'm trying to call this function which takes a double, or whether I'm trying to call this function which takes an integer. So now these two functions are different. So this is still a correct way to implement based on the caller, whether they are passing an integer value or whether they might be passing a double value. It will decide which one it needs to call. Okay, so far we are still talking about function overloading. Okay, we haven't yet started with function overriding, so don't confuse the two. Okay, so this is also another implementation of take damage, but this one takes a different argument uh, type as input. Okay, and the same with, like, if we have int and then we have another uh, int seconds as an argument. Now this one and this one could, conflict, because this is also same name and the same type of arguments, integer and integer, integer and integer, right? But if I change this value to say that it's a float, right, now there is no conflict, because when the caller calls the take damage function, if the first argument is an integer and the second is a float, then this one gets called. If the first argument is an integer and the second argument is also an integer, then this one gets called, right? There is no confusion anymore. If there is only one argument, then naturally this one gets called. Okay, so here we have added more functions with the same name, but with different context based on what is the type of the arguments. Okay. So there is a thing for even the return type. So if I have this as int, now we know that this will basically result in an error, right? But so far we talked about the function name and the integer, and the argument types, whether it's int, float, double, whatever it is, right? What do you think will happen if I change the return type of one of them? Do you think it will fix the error? Will the compiler say that these are now two different functions? Any thoughts, any suggestions, any guesses? What do you guys think? In case I change the return type, will that work? Will that fix this redeclaration error? Okay, so Sai says yes. Anyone else? Okay, Sai Kishore also says yes. Mangesh says error. Okay, so for folks who are saying yes, why do you think it will fix the error? What's the reason behind it? And Mangesh, the same for you as well. When you say that it will result in an error, what makes you think that that it will cause an error, right? And you know, the reason can be, hey, I don't know, I'm just taking a guess, like a random guess. That's perfectly fine as well. But let's try to think why, when we say something, why would that be the case? Whether it's a yes or a no, either ways. Why do you think that? Because return type differs from all other functions. Okay, okay. Hmm. Anyone else? Okay, so let's try and see what happens actually. So let's say I return an int. Right now it's complaining that it doesn't return a value. So let's say return 0. Okay, let's see the error. Functions that differ only in their return type cannot be overloaded. So seems like it's an error. I cannot overload functions that only differ in their return type. Now, can anybody explain me why? If you think back on day before yesterday's class, you'd probably be able to get the answer to this.
So return type should be same as the function which called it, I guess.
So if I'm calling it inside the main, do I always need to have an integer return type? So I'm calling all the take damage functions inside the main function, and main function has an integer type, right? So
Member function declaration with the same name and the same parameters. Be overloaded, sir.
with the same name and the same parameters, yes. But what happens if I only change the return type is what the question is, right? So here you see two functions that are exactly the same. Their argument lists are exactly of the same type, right? That means they should be overloaded. But right now I'm only changing the return type. One is void and one is int. So some folks mentioned that that should fix the error. Yes, it should work, but clearly we are getting an error, which exactly says that functions that only differ in their return type, such as these two functions, right? If they only differ in their return type, they cannot be overloaded. Okay, so let's imagine that I comment this out for now. Okay, so we have only one take damage implementation that takes in two integer numbers, and we have one implementation that takes in one integer. Okay, now when I call this take damage function, is one getting called or two getting called? So this is, I'm just call this function one, and I'm gonna call this, call it 3 so that I can call this as 2. So when I have, let me minimize these few classes that we don't need. So okay, so when I call this line number 70, is my 3 getting called or is my 1 getting called? Which one do you think is getting called? Ambiguity, why? Let me just hide away something so we can, guys can see both 3 and 1. Let me move this out of the way. Okay, so I'm calling line number 67. Okay, so line number 67 has a take damage function, and we have function 1 up here and function 3 here. So when I call this, which one do you think will get called? Line 67. Okay, so Roshan says 3. Anyone else? What do you guys think? Which one will get called? Okay, so Chaitanya says 3 as well. Others? Okay, Mangesh also 3. Okay. Okay, so pretty much everybody is saying 3 because it's clear that here we are passing in 2 arguments, and this is the only function that takes 2 arguments. This one takes 1 argument and this one takes 2 argument. Seems straightforward, right? So right now when I have an integer return value, now for the compiler to decide which function to get called, right? Whether it's this one, whenever I'm calling line 67, between 1 and 3, did it look at this return type to decide which one to get called? Yes or no? Okay. Any others? What do you guys think? Did it look at this return type of void versus int to decide which of the two functions to call when I had the line number 67? Okay, so others? So we have two no's. Yes, no, no, okay. So you guys are correct, right? It didn't have to look at the return type for two specific reasons. One, because it's very clear from the name of the function. So when I click on take damage, you see both the take damage gets highlighted, right? From the name of the function, it knows that it's one of these two functions. Then from the list of arguments, first an integer, then an integer, it knows that it needs to call this one because this is the only function that takes two integer arguments, correct? It never had to look at this integer or a void to make that decision. And the second reason for that is that it's up to the caller whether they use the return value or not. It's up to them. Even though here I have take damage that returns an integer value, and there could be any integer value in here, it doesn't matter, right? But I'm not even using that return value. I'm ignoring it. I'm just calling the function and that's it, right? Irrespective of whether I try to get that value return, I try to store that return value or not, right? Still the correct function will get called. And that is why it does not look at the type of the return value, because the return value can be ignored by the caller. The caller can ignore it, right? There is nothing mandatory that says that this take damage function has an integer, so I need to have an integer x is equal to something that stores this return value. If my program does not need it, I'm not going to create a unnecessary variable to store it. I'm just going to call function, and whatever the value is will get ignored. Whatever this return value is will get ignored. Okay. So the two reasons is that A, it detects which function to be called based on the name of the function and the type of arguments. Okay. So here the name of the function is take damage, and the type of the arguments are int comma int, right? Whereas in our previous example here, the name of the function is the same, but there is only one integer argument. So when I call the first function, player.take damage, the first one will get called. And when I call the second function, which passes in two arguments of both of the type integer, then this one will get called. Okay. Now, in case I create another player.take damage, and in this case, I pass in a damage value as integer, but then I pass in a float or a double or something like that, right? 0.0. How do we create floats in here? C# says F, but I'm not sure. Okay, so but point is basically if you pass in a float number here, then in that case it will be an error because it does not know how to. There is no function that takes in a float argument here, right? So irrespective of this return value, that return value is never checked, no matter what you do. Okay, because my caller can ignore those return values at any point. So based on the caller, you cannot decide on the return value whether it's supposed to go for this function or it's supposed to go for this function. Okay, so that is why we always want to make sure that we are passing in, we're creating functions that differ either on the name or on the list of arguments, right? The type. This damage can be DMG, it doesn't matter, like we looked at, right? This DMG doesn't matter. This could be also DMG, this could be damage, doesn't matter, but the type needs to differ. Okay. All right, cool. So hopefully that's clear. Yeah. Okay, I can remove this. We don't need. Okay, so the other example that we're going to look at is now we'll come to function overriding. So we said this function overloading is compile time, okay, but function overriding is runtime, and we'll talk about what that means. So at compiler, when the compiler is compiling the code and creating that uh, dot binary file, right, that the dot out file that you might have seen, um, or the exe file, in that case, that compiled code basically itself knows that this line needs to go to function type 1, and this line needs to go to function this one, right, because of the name and the arguments like we discussed right now. But what happens if we have, so let's look at one of the child classes. So I'm gonna remove this. So take player inherits from the player class, but my player class has take damage function. So I'm going to implement the similar take damage function in here. Okay. I'm right now just removing the code for now to show you guys how this will work. So for now, we'll just see out, and all we'll say is uh, player taking damage, and then the damage value, and then slashing. All right, this is mainly to see and understand which function gets called when we call um, based on the function overloading, sorry, function overriding. Okay, so here we are saying that player is taking damage because this is inside the player class, right? And inside the tank player class, which inherits from the player class, but it also implements its own function called take damage. Okay, this is tank player taking damage and then the damage amount. All right, so let's remove some of this we don't need. We just need one of them, and yeah, so we have, let's move it up. All right, so we have a player object and we call take damage on it, and then we have a tank object and we call take damage on it, and both are exactly the same functions. They take one integer argument as input. All right, now we have a take damage function um, inside our tank class, but remember, because there is inheritance, right, because there is inheritance, we have access to all the functionality inside the player parent class as well, right? This is exactly what we discussed, right? So all the functionality inside my player class will naturally come inside my tank player class as well. Okay, so first let's run this and I'll show you. So when we run this, let's see the output. So we're saying player taking damage, and the second line says tank player taking damage, right? So when we called tank player take damage, this line got executed. Okay, when we called player take damage, which is this first line, then this line got executed. So based on the type of object, so here it was a player object, but here it was a tank player object. Okay, so this probably seems kind of straightforward, right? So if we called it on the player object, then the player function gets called. If we call it on the if we call it on the tank player object, the take damage function, then the tank damage function gets called. Correct? Seems straightforward. What will happen if I comment this out and now run this? Now my tank player does not have any take damage function, right? There is no take damage function inside my tank player. So this line 64, will it result in an error? What do you guys think? Any thoughts? Will it be an error? Yes, no. Okay. Why do you say that that's not going to be an error? Seems like there should be an error, right? There's no function inside. There's no take damage function. We removed the function. We commented it out. So why do you say that we will not have an error? Inheritance. Okay. So what will I see? Okay. Okay. So will I see player first? We'll see because of this. We'll see player taking damage output, and then the second also will be like player taking damage input. Like instead of the second line, we'll see another line saying player taking damage. Is that what you guys are saying? Okay, so let's run this and see. Interesting. So now we get, in both cases, we see player taking damage. Even though we didn't change anything here, right? We removed this function from the tank player class. Still, we don't get any error. And instead, this gets called the take damage function in the player class. So like you guys mentioned in the chat, because of inheritance that we discussed in the previous class, that the tank player class gets a function, gets those same functions that are accessible in the player class based on this public inheritance. Okay. But the other thing to note is when I uncomment this out, in that case, this function gets called and not the function for the base class. That is function overriding. So the base class, the base player class implemented some logic for the take damage function. Okay. Whatever this logic was. For now, we have commented it out just for simplicity so we can see the output. But if we have actual full logic here, that means that our base player class implemented some take damage function. But if in my child class, I want some other implementation, okay? If I want some other implementation, then I can directly override it as well, right? I have hidden for this specific function, I have hidden away the take damage implementation of the superclass or the base class, and I am only using this new implementation that I have specified in my tank player class. Okay. Similarly, we have this high damage player, right? Now, if I created another high damage player, now in this case, I have this class as empty. And because it's inheriting, naturally the player implementation will get called. Okay. But in this specific tank, I know that I need some different logic for the tank to take damage. Maybe the tank has an extra bonus shield or something, and I need to check for that shield value before the tank can take damage, something like that, right? So then I can implement my custom logic. How I have this logic here, I could have implemented a custom logic and ignored the logic of this base class. All right. So this is called function overriding. So based on my context of which object I'm calling a function on, then it first gives preference to if there is a take damage function in this specific class itself. If there is a function of this type in this specific class, then that gets called. If it doesn't find it in this particular class, then it goes to its parent class. Okay, so in this case, it doesn't find a function which has take damage as a name and an integer argument. It doesn't find it. So naturally, what it does, it goes to its parent class, which is the player class. So if I run this, you'll see one implementation which says player, then tank player, and then again a player. Even though this last line came from the high damage player, right? But the high damage player was happy with the default implementation that is already inside the base class, so it doesn't need to create another function. So whenever you define a function inside the child class, you are hiding away the implementation that's in the base class, and that's why the name overriding. You're overriding it. Okay, hopefully that's clear. So based on the context of the object on which the object is called, that time you get to decide that which function will get called. And this happens at runtime. Okay, that at compile time, uh, the compiler cannot decide whether this object will always be of this type or not. We will look at this, why specifically it is runtime when we touch the topic of pointers and like memory allocation and such. So don't worry if you do not completely understand, hey, based on what we've discussed so far, you know, I know that this is a tank player. I know that this is a take damage function, and I know that its integer is an argument. Then why cannot compiler decide that it needs to be an object of exactly the tank class with this function with this argument? Then seems like it's very obvious that it always needs to call this, right? But we'll talk about this when we touch upon the topics of pointers and memory addresses and those kind of things. That why does the compiler defer this decision, not at compile time, but takes it at runtime instead? Okay, cool. So far so good. Any questions so far?
Sir, I have a query.
Mm-hmm.
Sir, I have a query. Sir, sir, the high damage, the function you created the below, high damage player.
Mm-hmm.
Sir, it's a abstract class, na sir?
Sorry,
Sir, it's an abstract class or what, sir?
no, it's not an abstract class. It's a normal class. It just doesn't have anything.
So, sir, it is inheriting the player class.
Yes.
So, it is accessing all the member functions of high damage player. Player,
Yes.
the base class.
Yes.
So, the high damage player is not having any member functions, right, sir?
Yeah.
So, the all things that high damage player has is the extraction from the player part.
Exactly.
So, isn't a abstract class, sir?
No.
So, can you, sir, please elaborate about the abstract class and all?
So we haven't talked about abstract classes, so I'll defer that question in detail for later. But the whole point, so since you brought it up, I'll just briefly mention it. So the reason why this is not an abstract class is because abstract class you cannot create an object from. Okay, what that means is that an abstract class is only there for the pure reason to say that this particular type of a class will have these members and these functions, but it doesn't implement any of those functions. Okay, so an abstract class will never have the body. So when you look at this function and when you look at this function, these functions have a body because they have something inside them. They have, even if it's just a return statement, they have something inside them. Okay, but an abstract class cannot have functions. It's when you say something is abstract, it's just a concept. Okay, in literal sense of the English word abstract. Forget C++, forget Java, forget everything else, right? When you say something is abstract, it's a concept, okay? It cannot have a physical thing attached to it. It's a pure concept, right? Like freedom. Freedom is a concept, right? It's not a thing that you hold in your hand, right? So an abstract class is also an actual idea of a class that when implemented will have a body, but otherwise it itself does not have a body, okay? Because because it does not have a body, that means you cannot create objects out of it, okay? So when you cannot create objects out of it, you cannot do this line number 68. You cannot create an object called high damage player. You cannot create an object called tank player if these were abstract classes. Okay.
Got it, sir.
Okay.
Got it, sir.
So yeah, we'll touch more in details on abstract classes. It in itself is it's a slightly bigger topic. So, but I just wanted to clarify since you had that specific question. Because this particular class does not have a body, it doesn't mean that this is abstract, because internally it's inheriting from the player class. So it naturally has everything that the inheritance lets it access from this player class by default, right? So it won't have access to this. All right, sorry. This keeps reconnecting certain at random times. Okay, we're back. So where was I? Yeah, so because we are doing public inheritance, you will have access to everything that's public. You'll not be able to access directly the private members because they're private, but you will be able to access everything that's public and protected. Okay, so if you think about it, the high damage player class internally has all this code as well. And that's why it is not abstract. It has code that is specific to, it has code of functions that have implementations, right? This is an implementation of this function. This is an implementation of this function. This class has an implementation of this function, right? So when you have an abstract class, it only literally defines one line of each function, which just says that it will have an take damage function, it will have an integer argument, it will have another integer argument, and that's it. It won't even say the return 1000 or return 10 or return 0, whatever, right? So that's the point of an abstract class. All right, cool. So any other questions so far? Nope. All right, cool. So predominantly we wanted to cover these two things today. So I'm not stretching too much in these initial few classes because I want to make sure that you guys are understanding all the details because these are the very sort of important concepts that are needed going forward as well. So most of the time you might have, understood them from a very theoretical concept level perspective, but understand that these are not just theoretical things. These are things that you will use pretty much every day, anytime you're implementing any kind of a project. Okay, so for those who were present in yesterday's session, we looked at some of the topics. So let me jump to one of an actual example. Again, this is not a C++ example, but I'll quickly show you the same thing that I showed folks yesterday. So this is one of the projects, one of the game projects that few of the students in one of the previous batches made. And I'm just going to show you how we have used inheritance, how we have used these basic 4 concepts of object-oriented programming in a real-world game project. One second, let me see. Where is it? Yeah, so here we are looking at a lot of different code that's implemented for different types of enemies. So this specific game had, these like 15, 20 different, no, well, not 15, I think 10 to 12 different types of enemies. So very much how you've been looking at we implemented one basic player class, and then we inherited the same player class to create different types of uh, different types of players. Same way here, if you see, we have one enemy class. The .cs is basically it's a C# file, so it's not C++, but the same concept of object-oriented programming remains the same, right? Like those key fundamentals don't change. So you have this one enemy controller class, and if you look at everything else is a different type of an enemy. So you have a static enemy, you have a target enemy, you have a circular enemy, you have an enemy that has a dog attached to it, etc. So you have these different types of enemies, and similar to how we have been looking at it, right? So where's my base enemy controller? I didn't open that file, sorry. So if you have this basic class, right? So you define this base enemy controller, and then you have a bunch of code inside it. But if you look at any of the specific enemy controllers, right? Like this is the dog enemy controller. It inherits from enemy controller. The syntax might be a little bit different from what we have seen so far, but you know, class, name, and then the inheritance hierarchy, right? That nature of things still remain the same, right? So here also, if you look at in C#, we specifically specify the word override. In C++, we don't have to do that, right? So the dog enemy class has this move to next node function, right? If I check for this function inside my regular uh, controller class, there it is, right? In this case, I've defined an empty function inside the base class so that anybody in the specific classes implement their own thing, whatever they want, right? Every enemy in the game moves in a different way, right? They have different animations, they have different things, the way they move on, right? But essentially, if you hide away all this complex 50, 60 lines of code, the core philosophy is exactly the same what we looked at here, right? This state damage function is exactly the same principle that is being used behind all of this extra code. It's just that it's a shit ton of extra code in there. So that, don't worry about that part, but understand that you'll see the same kind of behavior everywhere. Even I think, yeah, so move to next node even is in this class as well, right? And you'll see there's the override keyword. So here you have to specify that it's override. And again, it's of the protected type, much how we saw yesterday between public, private, and protected, right? So this function is also override. This function is also override. So you'll see that we are defining these functions inside the base class that perform the common set of operations. And then you can create a full hierarchy of things under it, right? Like a center node and then branches coming from it. And that gives you flexibility to modify certain pieces, right? If 90 enemies move exactly the same, you don't need to implement 90 classes and copy paste the code in all the 90 classes, right? Out of 100 enemies, only 10 enemies have a different move kind of a behavior. You can have the common move logic in the base class and only override them in the 10 separate classes. And the rest 90 all get the same functionality just by implementing it in one class, right? That's where the real power of object-oriented programming shines. Okay. So if you look at the very base class, so since somebody just asked about the abstract classes, so very similar to what we have an abstract class, we have something called as an interface as well, right? Again, the same idea that it cannot be, you cannot create a real world object out of it. It's just expresses an idea, right? It will not have any kind of a logic. So let me show you where this interface is. It might be in a different folder. Interfaces, okay. So we were looking at the enemy controller. So let's look at the enemy controller interface. So here you see, right? Much like an abstract class, all it does is it defines all the different functions that it needs to have. There is no body of these functions. Even the functions that have a return type doesn't have a return false or true inside it, right? Typically, when you have a bool, you would see like it will have a matching inside the parenthesis a return true or a return false, right? But this is very similar. The concept of an interface and abstract classes is very similar to each other in theory, where you cannot create an object of this type, of this thing, basically, right? How you created an object of a class, right? And putting an abstract keyword next to a class also tells the compiler that you cannot create an object from it. So if you look at this enemy controller, when we were looking at this enemy controller, which is the parent class of all the enemies, right? It's inheriting from this interface. How we have similarly inherited from other classes, right? It's inheriting from this interface. So the relationship is very similar. So you have a base class that's inheriting from an idea, and then you have these child classes that are inheriting from this actual class. Okay, so try to visualize it in your head. The only thing is that this idea cannot you cannot create an object out of this idea, but you can create an object of this class because it's not an abstract class. Okay, so hopefully that's clear. Don't worry about the interfaces. Since we just had a discussion regarding abstract, so I just wanted to mention it briefly. But the point is that there are things that you can create objects from, and then there are things like abstract classes and interfaces that you cannot create objects from. Okay, cool. So one thing I can briefly touch on is anyone familiar with the diamond problem? Anyone? Has anyone ever heard of the word called the diamond problem? Okay, I'll take it that you guys aren't familiar. Let me switch to whiteboard here. All right, hopefully others can see the whiteboard. Okay, 1 second, let me readjust my screen a little bit. All right, so basically what the diamond problem is imagine if you have a parent class A. All right, now you inherit and create a child class B, and we'll just take the example of the take damage function itself that we have been trying to implement for the last two classes, right? So like this function, this class has the take damage function. Okay, now you implement the same function in this class as well. You implement the take damage. Okay, and also in this class you take damage. Sorry about my crappy shitty handwriting. Okay, so seems clear. When you call take damage on the object of a class B, then naturally this function gets called, right? When you call an take damage on object of class C, then this function gets called, right? And same way, when you call it on an object of class A, this one gets called. And this is exactly what we have seen so far, right? What happens if you create a class D that inherits from both B and C? So it has something called as multiple inheritance, where it's inheriting from multiple classes at the same time. It doesn't implement its own take damage function, but what will happen if somebody calls the take damage function on the object of class D? What do you think will happen? Can anyone take a guess? Okay, so Mangesh says in Java it's not possible, it's an error. Okay, others? Anyone else? Okay, so error is specific to Java, right? But ignore Java, ignore C#, ignore C++. Just use logic, right? Like just abstract logic, right? Just think about it. What do you think logically should happen, right? What does your intuition tell you that should happen now when I try to call the same function that is now present in all these three classes, and I'm calling it on the class D? Okay, so It will inherit from both C and D, yeah, or from both B and C, yes. But which one will it get called? It's not possible that when I say D dot take damage, it's not possible to have both B and C functions get called, and maybe then A also gets called, right? When I say one function call, only one specific function with that same name should get called, right? So how will compiler know which one to call? Will it call the B one? Will it call the C one? Or fucking God knows, will it call the A one? I don't know, right? So seems illogical. We don't know. There is no real way to figure out, right? Somebody might say, oh, if I wrote the, while inheriting, if I wrote the name of the class B first, let's just call B1. If I wrote the name of the class C first, if I was inheriting something like public class D colon, 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 and then B first, one sec, sorry. So if I was doing something like, uh, class D and then inheriting saying public B and then public C, right? Now here I'm specifying public B first. So let's call the B1 first in case I change the order and switch it to like public B. Now the C1 will get called, right? Now the behavior is inconsistent, right? How somebody implemented it, it will keep changing. In Java, it results in an error, right? So this is a typical diamond problem that happens when you have multiple inheritance. So as a general rule, most languages have gone ahead and said that we are not going to support multiple inheritance. So as a rule, majority languages don't support multiple inheritance, Java being one example, C# being another, right? So you do not have the capability to have two classes, one class import from more than one class at a time. Sorry, inherit from one class at a time. So this is typically called as, referred to as the diamond problem. So generally, if you still want to do that, the only reason for why you would ever want to inherit from multiple classes is because you want some functionality that was present here, and you want some functionality that was present here, and maybe some functionality that was present here, right? The only reason to keep inheriting something from another class is because you want some of its functionality, right? So if you have a player and then you have a building, you will not inherit the building class from a player class, right? Because player and buildings don't have anything in common. One is a structure and one is a person, right? They don't have anything. A building class would not inherit from the player class because player implements a move function and the building class needs a move function. No, right? So naturally you only inherit when you need some functionality that is common to your higher level classes, right? So that's why the concept of abstract classes and that's why the concept of interfaces was introduced. Now we saw a quick example of an interface. Second, let me switch back. Yeah, so we saw a quick example of an interface. Now what this does is it says that anybody who um, implements this interface, right? Like how we saw in case of our, where is my enemy controller? Yeah. So how we saw in case of the enemy controller class, whoever implements this interface uh, ensures that there is a reset function of the type void. There is a get current node ID function which returns an integer. If you do not implement, and like even if you miss out one function of this list, that will result in an error. So you pick up any of these functions, right? And exactly the same function will be implemented in the class that implements this interface. Okay, so is scalable, I just picked up this random function. Now this class implements this interface, and if I control find, there's this function, right? It tells me whether this player or this enemy is killable via this specific kill mode, right? If it has a shield, then can it be killed by shooting, return true, else return false. So whatever is its internal logic is dictated by this particular function. Okay, This is another example of abstraction that we talked earlier today, right? We are hiding away these complexities so that somebody outside can call and say, hey, enemy, are you killable if I shoot you? Like, will you get shot if I shoot you? Right? And the enemy implements and says, yeah, I can be shot. Otherwise, if it has a shield or something, then it says, no. If it has a shield, then it returns false, right? Hey, I have a shield. You can't shoot me, right? So that is what we were talking about earlier when we were talking about abstraction, the concept of abstraction, right? Cool. So we got slightly off topic today, especially with the interfaces stuff. In case it's not clear, anything like that, feel free to ping on Discord as well, or you can, uh, this is just to kind of give you an overview, uh, basically of what these core concepts are, and give you even an example of how we use these in like a real project, right? I can quickly show you guys the video of this game as well, so you can get a sense of what this game look like. So it is fairly complex game. I'll put the link in Discord as well for this video. So don't worry in case you're not able to, like if the streaming is not up to speed. But here you see like this black player is, this black guy is my enemy. It's my player. It's a turn-based game. So all the enemies that you see, they have their own mechanics, right? So some enemies move, some enemies are static, and using inheritance. This is all implemented through inheritance, right? So these yellow guys are always moving back and forth on a fixed path. Then you see these sniper guys who are shooting and they don't move, they just stand in one location, right? So all this is possible because you have this inheritance hierarchy of different enemy classes, right? So you have this one guy who's standing in the right corner, and just rotates with a knife. Uh, and then you have this specific enemy that has like two bodyguards looking, away from each other. And if you come in front of them, they'll kill you. So I'll share the video in the chat here. In case anybody's interested, you guys can just check it out yourself. But the point is that even though you might have learned inheritance from a very theoretical concepts and other object-oriented, philosophies from a very theoretical perspective, but these actually get used every day on a day-to-day basis when you're working on live projects, when you're working on real projects. I've given you an example of a game, but the same will apply when you're building a web application, when you're building an Android application, no matter what. That's why this is the first module that we cover, irrespective of what programming you want to learn. Um, so yeah, hopefully that gives you a good overview of all the object-oriented concepts